Okay, let's go ahead and jump into special right triangles notes. So, all right, so, sorry, it's a little janky looking. All right, so special right triangles are pretty much what they sound like. They're right triangles that are special. Okay, so there are two that you need to know. One is called the 45-45-90 because it has a 45-degree angle here, here, and then a 90-degree obviously right there. And then we have the 30-60-90 for the same reasons. We have our 30-degree angle, our 60-degree angle, and our 90-degree angle. Don't forget that the two acute angles in a right triangle have to add up to be 90. Just throwing that out there. Okay, so let's start with the 45-45-90. So this is obviously an isosceles triangle. So this is an isosceles right triangle because the two legs are congruent. And let's just, and this is obviously the hypotenuse. Okay, so let's say you have a problem. You are given the length of one of the legs. So it says, oh, there's a isosceles right triangle has a leg with a length of like 5 or something. All right, so what you need to do is that you multiply the leg by square root of 2, and then that's going to equal the hypotenuse's length. Let's say that you know the hypotenuse, and now you need to figure out how long the leg is. Because you don't know that, then you divide by the square root of 2. Okay, so basically the rule for this one is just either multiply by square root of 2 if you're going from leg to hypotenuse, and if you're going from hypotenuse to leg, you just divide by the square root of 2. All right, additional facts. The legs are congruent. Ooh, not what I meant to do. Sorry about that. Okay, so the legs are sorry about that. The legs are congruent, therefore this triangle is classified as an isosceles. We just talked about that up there. Right triangle. A 45-45-90 triangle can be created by cutting a square diagonally in half. Okay, so if you see something with a square, like a problem with a square, and that does not look like a square, it's a little bit better, and then you cut it in half like that, then this would be a 45-45-90 problem. Okay, let's talk about the 30-60-90. So this one, it also has its own set of rules here on the left side. So if let's just take a look at the triangle first. So it has a short leg, boom. It has a long leg, boom. And then it has the hypotenuse, of course, which is there. So that's what we're going to be talking about. So if you know the length of the short leg, and then you have to figure out the length of the hypotenuse, you're going to multiply the short leg by 2. Okay, so you can see when we're going from x to 2x, you just multiply by 2. Then if you know the short leg, but you need to figure out the long leg, well, this time you're going to multiply by the square root of 3. Take x, or whatever the short leg's length is, and then multiply by the square root of 3, hypotenuse. So if you start with the hypotenuse this time, and you need to figure out the short leg, that means you're kind of going backwards in essence, so we're going to divide by 2. And then, if you know the long leg and you need to figure out the short leg, you divide by the square root of 3. All right. Additional facts are that a 30-60-90 triangle can be created by cutting a equilateral triangle in half. Okay, so if you have an equilateral triangle, you should remember that all the angles are 60, so that's 60, 60, and 60 degrees. And then if you cut this in half like that, it's going to create a 30-60-90 because now this part over here is 30 degrees. You see what I'm saying? So just keep that in mind. The short leg is always across from the 30-degree angle, and the long leg is always across from the 60-degree angle. I didn't have to put the word angle there. I mean the symbol for angle, my bad. Okay, so again, long leg is across from 60 degrees, and then short leg is always going to be across from 30 degrees. Okay? All right, that pretty much sums it up.